Hello, ladies and gentlemen. Look at that. There's no CNC machine there. As a matter of fact, it's down there in a big pile. Oh, it's over there. And there's pieces over there and over there. Okay, so version 2. How about that? Let's start with the mistakes we've made. That's version 1. That is 1 inch by 1.5 inch rectangle tube, box tube. And that is 0.65 wall thickness, 0.065 inches, or 16 gauge metal. Okay? So that's version 1. That's this. That's an upright right there going to the gantry. That's that. Okay. Version 2 is that. Let's look at these together, shall we? Slight difference. New, old, shaky, not shaky. So, beyond that, this is a piece of angle iron. That is 1/4 inch by 2.5 angle iron. It weighs a ton. It is a big, giant chunk of steel. Now, if we remove one of these glides, I just got everything kind of mocked up here just so I can kind of start seeing how this is going to go together. This piece of, let me get this out of here. This piece of angle iron is going to affix to the frame like that. Okay, so here's the frame, and then angle iron, and you can see the rails will attach to the angle iron. So this will all be welded here. These will be sistered together, the angle iron and the outside frame. So basically we have 1/4 inch and 3/16 inch wall. We have almost a 1/2 inch thick metal between these two. Right here, there and there. We have almost 3/4 inch if you include both sides of the box tube plus the angle iron. It is gargantuan. Not to mention, you know, we're going to be welded there, underside, and around. I mean, just everything will be tied in. It'll be just incredible. Just an incredible amount of steel. Thick, heavy steel. This frame alone's got to weigh 70 pounds, 75 pounds as it sits now. I mean, it's just... Even without the angle iron, I mean, it's with the angle iron attached. This is probably 100 pounds. I mean, just one single frame assembly, and the 2 supports for the glides. It's incredible. This is not going to move an inch. I made some pretty corners. All right. This is what those flap discs do on an angle grinder. It just makes everything so pretty and smooth. And then, oh, here, sorry, finger. I, at one point, had a gorgeous square hole cut in this, perfect for a NEMA 23 stepper motor to fit through. And I actually had a hole on this side with 4 mounting holes for that motor to mount to this side of this, and that it was perfect. It was centered perfectly this way. The square hole matched up with the hole on the other side. The motor fit right through. It was perfect, and very much on the wrong side of the machine. So God bless metalwork. I was able to just put the square piece right back in and clean it up. Luckily, I have a giant piece of angle iron sistered over the cut, so I don't have to worry about support issues, and it's pretty darn close as it sits now. Hit it with a little Bondo before I paint, and you'll never know that happened. So, but it also leads to the problem, excuse me, of now cutting a hole in this, but more importantly, drilling an 1.5 inch hole on this side. And it's going to be mighty interesting to get this entire frame on the drill press to allow me to drill that hole. In previous videos, I've talked about order of operations is what gives you accuracy, and this is an order of operations issue. This hole, this mounting hole for the motor to fit through the tube and mount to this side of the box, and the square hole for the motor to fit through are it is far easier to lay those out, find a center line, cut them, machine them, when this is a single piece of metal. Now that it's a frame and I've got to go back a step and fix a mistake I made, it's going to be far more problematic and more prone to being inaccurate doing it this way. But you got to do what you got to do. So I'm going to redo these plates. Actually, I'm going to when these plates slide down here, I'm actually going to have a bit of table. You know, the table is 24 inches. That's an 8-inch block, which I'm actually going to make I'm going to make it a little bit wider, 9 inches. And then I've got a table at 24 inches sort of balanced on top of that. So I thought it'd be better to kind of make these guys a little longer if I could. So what I'm going to do is I'm actually going to notch this angle iron to fit over this. This whole plate will be a little longer, and then it'll notch over. So when it slides to one end or the other, this angle iron will continue above this box tube with the table on top of it, with just a notch to clear this. And so hopefully that will be more of like one sort of member. Actually, here I'll have a cross member coming, across here to the corresponding plate on this side, and it will actually mount like that and fit up and over the box tube. When it slides this way, it'll end up just like that. And then, like I said, the table will sit on top of this and protrude a little bit farther. So I will have to paint some big red and white stripes here, and the finger getting cut off to picture, because that right there is waiting for your fingers to literally be chopped off by the table as it slides by. And then finally, we'll have a piece of box tube coming up. Let's see if we can look at this side and maybe we have more light. We'll have box tube coming up for the gantry, and then more of the box tube coming down as two diagonals from that upright going all the way down to the corners. Again, all of this 3/16 box tube. I mean, it's just, it's so heavy, it's awesome. And then from there, two pieces of angle iron going across, similar to this, but much wider and much heavier than this 1/8 inch plate that I used. Like I said, 1/4 inch. So it's going to be substantially beefier. So there we go. Oh, one last thing. I know I will have critics that are going to tag me on this. That's a rookie. That's a rookie right there. The seam is on the outside. The seam should be on the inside. Well, I just want everyone to know that's done for a reason. Number one, when the motor attaches to this face on the inside, I can't have this ridge. There's a ridge where the seam is on the inside of the box tube, and I have to have the motor sit flat to this plate on the inside, so I have to have the seam on the outside here. But beyond that, I'm using an abrasive blade chop saw to cut this stuff, and the blade gets smaller as you use it, and there's a point at which the blade is small enough it is physically too small to get through this box tube, and this is so thick I'm eating blades alive. So cutting a 45 and then flipping the metal over and using the remaining 45 that was cut off of the stock, for the next piece, allowed me to cut all four of these corners, missing 4 cuts. I mean, I reduced the number of cuts I had to make by 4 by flipping the metal over, and thus one seam is in, one seam is out, one seam is in, one seam is out. But it's just really a little bit more work for me. I'll hit this with a flap disc and just sand it down and make it go away. Little putty, little paint, make it what it ain't, and you'll never ever know that that is the case. So that was done as an executive decision. There's a reason I did it that way. So there you go. There is the start of version 2. It is big. It is extraordinarily heavy. And we're going with the fixed gantry and the sliding table. So there you go. We are starting. Hopefully, I've got a big day tomorrow. I won't be able to work on this, but hopefully Sunday I'll find some time, and Monday or Sunday night, hopefully you'll see some more progress. But we're getting there. This one's going to work. This one's going to be awesome and flex free. Ting!